Welcome to Test Equipment Chronicles with Bob. Today we're going to test a voltage regulator off just a common old Ford alternator internal regulator. The idea here is to actually understand how you can bench test components. When in doubt, if you're going to take a new one out of the box or reusing an older component, or simply want to verify and not sure exactly how to test it on the car or incapable of testing it on the car, say the engine doesn't run. So let's go ahead and get it going here. First thing we need to do is turn on our test bench here. And what we're going to do is I have the wires simply hooked up to this simple voltage regulator. I'm coming off of a pulse width modulated regulator here. So this is simply doing is regulating voltage coming out to hence our another voltage regulator. And what we want to do is we want to make sure that it can actually pass some current. In a normal configuration, what it would be doing is it would be applying current to the brushes that would go to the slip ring, that would go to the rotor on the alternator. So current would be applied through here and then ultimately through the brushes. In this particular case, we're going to simply use the headlight as the current load source. So that would take the place of the rotor itself. So let's go ahead, and you can see here we have voltage available, but I have not triggered the voltage regulator yet. I want to do is I want to measure how much current is coming through. So we'll set our amp meter up. I do have the Zeus set up for amperage. So we're going to be in a 20 amp scale. And what I'm going to do is I'm going to go ahead and zero just to make sure we're at zeroed. And then simply go over, and what I need to do is determine what lead I want to hook up to here. So that I want to do is see the ignition, same as if you turn the ignition system on. Okay, ignition system's been turned on. Now we can see that we do have current here, and it's pulse width modulated. So this voltage regulator is illuminating the light. As I turn up the current to it, you can see our voltage here rose, and that is simply monitoring our incoming voltage. And this would be the representation on our ground, since it's a ground side control. So we'd have power to one side here, and then we'd be supplying a ground to the other. And so through the slip rings to the rotor, like I explained earlier. And so what we're doing is we're looking at, this would be full power. We're literally down against the transistor level. So we're at full current of what this light bulb can absorb. So if I turn the current down a little bit, you'll see the light bulb dimming. And you can also see at this point here, our pulse width is changing. Instead of being 100% on time, we're now getting a varying reduced amount of current to the field. Now grant you my voltage is low, but you can see here we're just shy of 8 volts, but we're still down on the bottom end. There's going to be a point where of course there would be no voltage available to do the job. But the regulator, and the goal here was to determine, can this regulator actually function? This regulator is perfectly good from the alternator firing up and charging standpoint. That regulator gets a full bill of health. So hope you learned something in this. Make sure you subscribe and comment, and I appreciate it, and have a most wonderful day.